For this video, we're going to continue to geometrically find definite integrals. So for this problem, we're integrating from 1 to 3 of the function f of x equals -4. And then it's with respect to x. So if I draw the graph of this, -4 is a horizontal line 4 units below the x-axis. Then I'm finding the area from x equals 1 to x equals 3. Or it would be the area if this were non-negative. But because it's below, we're still going to find the area of this region, but we're going to assign a negative value to it. Our y value is negative. So it doesn't represent the area anymore. The area of this region would be 2 times 4 equals 8. And areas can't be negative, so I'm not going to say that this integral equals the area, but it is related to the area. We're going to say that this definite integral equals -8. This integral here, the integral from 0 to 3 of 2x minus 1 dx. To do this, the first thing I would do is draw my graph. So we're going to start at x equals 0. When x equals 0, 2 times 0 minus 1 is -1. It's a -1 right there. And we're going to go until x equals 3. When x equals 3, the value of my function that I'm integrating is 2 times 3, 6 minus 1 is 5. So it's at that height right there. And I know that it's linear, it's a straight line. So I can actually find the value of this definite integral using areas, but it will not represent the area itself because my function is not above or on the x-axis for the entire region I'm looking at. So what I need to do is figure out when does it actually cross the x-axis. So I'm going to set my function equal to 0. So x will equal 1/2. So that's this point right here. So I'm going to look at this as two separate triangles. This little triangle right here will have a negative area. And I know that the area of a triangle is 1/2 base times height. The base is going to be a 1/2. And my height is going to be a 1. So this region right here has an area of 1/4. And I'm going to assign a negative value to it because it's below the x-axis. If I look at this triangle right here, it's going to get a positive value because it's above the x-axis. So the area of this triangle is 1/2 base times height. My base will be, we're going all the way out to 3, but we're starting at 1/2, so it's 2.5 or 5 halves, times a height of 5. So this will equal 25/4, and it gets the positive value. So my total combined will be 25/4, which is positive, and then I'll add in the -1/4 or subtract 1/4, and I get 24/4 or 6. So this definite integral is equal to 6. Now, two special definite integrals to look at. If f is defined at x equals a and you're actually integrating from a to a, so you can imagine on a graph, here's your a, and there's a point there, and you're integrating from a to a and you're trying to just figure out what is this area. Well, there isn't any area under that because you have no width. So this integral will be 0. So if your limits of integration are ever the same, your answer is always 0. Next, if f is integrable on a to b, on the closed interval a to b, then if you actually have your higher number as your lower limit of integration, that doesn't mean you have to do this entire new process. You can actually just turn your integral symbol over by putting a -1. So it will be the opposite in sign of your integrals if it was normal from a to b. So instead of actually doing this new process, you can always just turn your integral symbol over and actually put a negative sign on. It will be opposite in sign. So knowing that, We have some more examples here, and some of them will look complicated, but they aren't. If you look at this, you're integrating sine x dx, and some people might think, I don't know how to find the area under the sine curve. Well, if you check your limits of integration, you're integrating from pi to pi, which means 0 width, which means 0 area. And that's done. This problem, if you look, the higher number is the lower limit of integration, so this will actually equal the opposite of the integral from 0 to 3 of x plus 2 dx. So we actually already found that integral on the previous video, and that integral was 6. So this would equal negative 6. Some problems that I actually enjoy doing, they're puzzles, if they actually give you some integrals numerically. So let's say that we are given some function f of x. They didn't tell us what the function was, but we know that if we integrate from -4 to 3, we get a value of 1. And if you integrate from 0 to 3, you get a value of 6. Then they start asking you other questions about it. Well, what you can always do is just break these down piece by piece. Geometrically, you have this function f of x, and you're lowering it by 2. So the entire function is moving 2 down, which will subtract some area, but it won't subtract an area of 2. It's whatever rectangle has a height of 2 from 0 to -4. The way I like to actually do it is break this up, and you're going to integrate term by term. So this is the integral from -4 to 0 of f of x minus the integral from and there's a dx right here, shame on me, minus the integral from -4 to 0 of 2 dx. Well, from information I have up here, I can probably figure out this, and I know what this will be. If I look at this piece graphically, if I graph y equals 2, up 2, and I went the wrong direction, so we'll say from -4 to 0 at a height of 2, this is 2, this is 4, this area is 8, so I'm going to be subtracting 8 from this. And again, as I said, you're taking this entire function, moving it down 2, so you're putting in that rectangle, it's a 2 times 8. So we're subtracting 8. To find the integral from -4 to 0, I actually draw a number line. So I'm going to take a number line, and I'm going to put all my important values on it. My important values are my x values. Remember, these dx's tell us that these are x values. So my important x values are -4, 0, and 3 if I put them in order. So I have a -4, 0's in the middle, and 3's out in the end. And I don't worry about size here. I'm just going to write some numbers on my number line. So if I start at -4 and go all the way to 3, my integral is 1. If I start at 0 and go to 3, my integral is 6. What I know is that my pieces have to add up to my whole. So -4 to 0 plus 0 to 3 has to equal -4 to 3. So I can figure out what this value is just by putting an x here really simply and say, oh, x plus 6 has to equal 1. So my x equals -5. So the integral from -4 to 0 is -5. So I have a -5 minus 8 equals -13. If I look at this problem, this 2 that's in here is just a scalar, it's a number, so it can come outside of my integral. And then I'm going to integrate this term by term, 3 to -4, and I notice right away we have a problem. My limits of integration are backwards, and I'll just fix those. And then I'll put a minus the integral of 1 from 3 to -4 dx. So fixing all of these, it's from 3 to 0. I'm going to say that this is 2, and I want it to be from 0 to 3, so I'll put a -1. And then this is 3 to -4, but I want -4 to 0, so I'll put a -1, which actually changes that to positive. And the same thing here, so plus the integral from -4 to 3 of 1 dx. I can come back up here to my number line to figure these out. From 0 to 3, the integral is 6, so this will be -2 times 6, plus the integral from -4 to 3, the whole thing is 1. And then here I'm integrating 1 from -4 to 3. So remember that this will be something that has a height of 1, y equals 1, from -4 to 3. So the width will be 7. So it'll be plus 7. So this will equal -12 plus 8, or -4. And that problem is finished.